Hello, everyone. Thank you for joining us. We are delighted to be here today to share our story. But first, I'd like to introduce you to my colleague, MJ Wood, a senior urban designer and geodesign advocate in our London office. And I'm Shannon McIlvaney, the Global Director of Geodesign, based out of Colorado in the US. Since our story begins in London, I thought I'd start with a literary reference. You've heard of Charles Dickens' A Tale of Two Cities. Well, this is a tale of two methods. One siloed, mostly paper and disjointed. The other collaborative and integrative. One more static and singular in focus. The other more dynamic, holistic, and innovative. It's really a story of digital transformation, the future of planning and plan review, and it applies to anyone doing planning, whether you be an AEC firm or in local government or part of the community. And the main actor in this story of digital transformation is geodesign, a powerful planning method that uses stakeholder input in spatial analytics to simulate the possible impact of alternative scenarios. Turning technology into a facilitator, it allows us to reframe what it means to be a smart city, going beyond smart meters to help us blend the right amount of high tech with place-based solutions. It is a collaborative systems approach to context-sensitive planning that turns data into rich information, enabling leaders to make better, more informed decisions. And when built on a spatially enabled digital backbone, a common data environment, the cloud, whatever you want to call it, well then, that's when smart planning leads to truly sustainable and resilient communities. Which brings us to Meridian Water, the story of a redevelopment that seeks to create an affordable, walkable, sustainable, and resilient neighborhood in one of the most expensive cities in the world. Our geodesign approach started by building a common data environment, an environment that supports the integration of data of all kinds. It is at the heart of the Meridian Water program, working to turn vision and values into a thriving neighborhood. And the benefits are many, from the unexpected synergies to be had by sharing data across disciplines, to the ability to improve social capital, so essential to resilience. But there's a twist to this geodesign story, and what good project doesn't include a little adventure? And for that, I'm going to yield the stage to the person closest to this project. MJ?
Thank you, Shannon, and hi, everyone. Today I'm going to take you through the various ways in which we have been implementing a geodesign approach in a very unique way to support innovation, collaboration, resilience, and ultimately achieving the vision for the Meridian Water project. In this presentation, we'll firstly set the scene for the project with an overview, and then we will explore how the team tackled various challenges to develop a bespoke process of data integration and optimization. Thirdly, we will look at how we use this integrated data set to analyze the performance of the master plan against key project targets. And finally, we'll run through some of our all-important lessons learned. Now to provide you with some context for the project. Meridian Water is one of London's largest regeneration opportunities. It's an 82-hectare brownfield site set to provide 10,000 new homes and 6,000 jobs within a very constrained yet beautiful and strategically located site in the capital. The project is led by the London Borough Council Enfield, who have adopted a pioneering approach as the master developer for the project and are ultimately the custodians of the place Meridian Water will become, ensuring the development meets the agreed social, environmental, economic and placemaking objectives as set out across a series of strategies. This complex project consists of many interdependencies and sub-projects, including several individual sites, environmentally sensitive groundworks, a meanwhile use strategy, planning policies, enabling infrastructure, and the overarching master plan itself. When we joined the ever-growing multidisciplinary team back in early 2020, the second version or iteration of the master plan was in the early design and planning stages. A new team of various architecture, landscape, environmental and technical consultants have been brought together to develop a high-quality, sustainable and viable design solution for the site. The master planning vision for the site is to take this light industrial area and knit the urban fabric defined by the waterways back into its environment, while creating a distinctive new neighbourhood. Site-wide master planning and infrastructure strategies are proposed to realise the site's opportunities and to unlock its constraints, which are informed by three key placemaking pillars. These are mixing uses and animating streets, park life on your doorstep, and your place to make and create. So what was the challenge? Well, our role was to design, build and implement a digital platform that could integrate all existing geotechnical data produced to date, and at the same time to use this solution to both visualize and analyze the master plan as it's being developed by the various design and technical teams. So not only did the team need to test new ways of transforming various data types of differing scales, but we also had to work with live iterative data that required drafting specifications to ensure its efficient integration into a single or series of compatible datasets. We would also need a common data environment or a platform at the heart of this project to encourage data accessibility, support innovative interdisciplinary solutions, maximize efficiencies, and ultimately to promote collaborative and data-driven design decisions. So what do we set out to do? Well, this goes back to what Shannon mentioned as our twist to the geodesign approach, in that we implemented the geodesign methodology as a way to review both iterative and baseline design data as they are received, and we analyse this to ensure the design is meeting the vision set forward by Enfield Council. And where it wasn't working, alternatives could be tested live within City Engine, for instance, or scenario designs could be generated externally and then processed for analysis again. We use Esri platforms and tools such as City Engine, ArcPro and Portal to enable the integration of data from a variety of sources to create highly visual 2D and 3D models to enable the team to challenge the design in terms of its performance. The solution is fundamentally about being driven by the data, both in the iterative design data we embedded within the process, but also outcomes-based, in that the overall design needs to be tested against those three overarching placemaking pillars that I previously mentioned. All of this is carried out on a regular basis in a workflow cycle that became more and more efficient over time. In terms of this workflow, firstly we have the project objectives that operate across scales. Then we have to produce or acquire the relevant project data required to measure the performance of these objectives. With this data, we carry out the process of analysis, which is carried out in a number of ways by embedding agreed assumptions and calculations. And then finally, we produce the digital outputs themselves, which allows the team to review, workshop, and make decisions. Now we're going to take a look at the process in a little more detail in terms of data optimization, integration, and transformational flows. So what this diagram does is it really expands on that previous workflow cycle that I showed, and it gives more detail and examples throughout. It essentially captures the process that the team would carry out on a fortnightly cycle last year. The three placemaking pillars are not yet quantifiable, so these were then translated into an extensive matrix of agreed project ambitions, key performance indicators, and targets. These targets cover various themes of open space, density, housing, sustainability, environment, and transport, for instance, which operate over varying scales and contribute to the performance of individual buildings, to the site itself, and the borough region. To give you an example of how it worked, if I take the placemaking pillar of Park Life at Your Doorstep, this is translated into a series of KPIs and targets, such as maximum walking distance for all residents to a local park, or the percentage of public open space provided across the site. At step 3, we would acquire the data. In this case, we would need the proposed distribution of residential units and open space typologies across the entire site, and we'd need to map physical barriers and walking routes together with embedding assumptions of walking and cycling times. These multiple data sets are then integrated, and we then publish the consolidated database and produce published outputs using various Esri software to analyze further, visualize, and communicate the performance back to the wider team. In this case, we might produce a dashboard for the open space metrics and 2D web maps to communicate accessibility. All of these outputs are then hosted onto our project portal and are available for all to view and to discuss a way forward. The data library consisted of both baseline and live data sets of various formats coming from multiple consultants. Some examples of file types were 2D DWGs from the master planning and landscape components, IFC files that contained 3D buildings with embedded attributes, existing BIM models of built assets on the site, and other 3D topo DAE files. The data sets are then run through a bespoke automated FME workbench wherein those KPI-related assumptions are applied, which generates further relationship-based metrics. Here's a quick demo to show you an example of the master plan hosted on a web scene, highlighting the integration of an external BIM model, in our case, the Meridian Water train station. This enables us to host external development models in a single 3D environment to allow us to assess their impacts simultaneously. Here we demonstrate how importing the proposed 3D contour model that was translated into a Collada file enabled the team to visualize how flooding scenarios would transform the experience of a large open space into a productive wetland. This allowed us to make technical design changes to the engineered landscape to ensure the gradients and accessible open space were adequate during times of flooding. Now, if we go back to the process of data optimization, a key stage and lesson learned for us was establishing a weekly process of data auditing and ensuring that we issued detailed drafting specifications to the various consultants who were producing new data of different file types. This enabled us to continue to enhance the project efficiencies week on week. Once the data is audited and processed with an FME, we take this iterative design and baseline data into City Engine, wherein we apply a series of scripts to generate both detailed visualizations of typologies and also to create key design metrics. This data is then formalized and published through a series of 3D web scenes, dashboards, and 2D maps, which enables visualization and a detailed assessment of the current design. That being said, we were also able to measure some of these metrics live within City Engine, which meant we could workshop several scenarios and assess both the design and quantitative metrics at the same time. As an example, we could use the Viewshed Analysis tool and take a particular floor from any building and assess the percentage views from each facade to open space, roads and buildings, which could inform the value of those units and feed into the financial model. Any changes made to the design could then be exported back to the design team to take on board as a design alternative or change. We could also look at a particular part of the site and quickly work up some massing scenarios. We can view the total floor area by land use, the number of jobs the neighbourhood generates, the quantum of new housing and the urban density. We can efficiently then switch to a second scenario and see the metrics in parallel or compare several options side by side. So what we'll do now is take a look at the various types of digital outputs the team produced as part of this iterative working cycle. So looking at those three initial project objectives, we'd like to take you through each one and demonstrate how we translated it into a series of quantifiable targets and provide a quick demo of the various assessment models used to analyze and visualize this. So taking the first objective, mixing uses and animating streets. This is all about how the master plan can encourage activity and animate the site with a diverse mix of land uses, open spaces and public realm to create a vibrant new neighbourhood supported by a network of sustainable, safe and legible movement routes. Now, in terms of translating this into measurable targets, it's important to note that some metrics will be quantitative and others are more subjective and qualitative in terms of creating a desirable and sustainable sense of place. Here we've included just a few example targets, such as achieving 2/3 active land use for all ground floor uses, enabling a 400-metre minimum distance to bus stops from all residential buildings, and also in terms of something more qualitative, this could be providing high-quality movement and transport networks. Now we'll take a look at how we measured some of these. This is one of the dashboards we produced that reports the percentage ground floor active uses, which at this stage was only 44.8%. so we could then look at the percentage across the different neighbourhoods and identify locations to introduce other uses in order to hit that target. It also reports the total employment generated and provides a detailed breakdown of active uses. In terms of assessing the quality of proposed movement networks across the site, we adapted scripts within City Engine to generate multiple detailed streetscape typologies that were proposed by the design team as 2D drawings. This meant that we could better understand the scale and quality of the streets and ensure they are promoting high-quality placemaking design principles. The second overarching objective is park life at your doorstep, and how Meridian Water is to become the greenest development in London. In terms of targets, these included a minimum of 10 square metres of play space per child, located within 400 metres of all residential buildings, and providing at least 30% public open space across the entirety of the site. In this dashboard, you can see at this stage we were hitting 28.4% total public open space, but actually achieving 35.4% when we include smaller public realm and other typologies. And in terms of play space, we weren't far off at 9.24 square metres per child. And you can see how all of these open spaces are distributed across the master plan on the right, including community gardens that can support a more sustainable lifestyle and a local circular economy. In order to promote healthy lifestyles and a walkable neighbourhood, we ran accessibility maps to analyse the distance in metres and timings for all residents to public open space, local parks, play space, waterfronts, and the continuous green loop that runs through the heart of the site. The third objective is your place to make and create, which really builds upon a series of successful makerspaces that currently exist within the site. These should be protected and further enhanced to create a place that supports innovation, creativity, and production. Some of the targets set out to achieve this were a detailed and diverse employment profile split, including 23% small studio space, and ensuring employment uses are easily accessible to all users across the site. In this dashboard, we analyse how each neighbourhood is performing in terms of its land use breakdown, including detailed employment types, the split of ground floor active uses, and the overall ratio of residential to non-residential land use in that area. This enables us to better understand the product, the character, and the USP of each neighbourhood. In terms of accessibility, we wanted to ensure that throughout the 20-year phasing of the site, residents would have good access to both social infrastructure and commercial uses by walking and cycling. Where this was underperforming in a particular phase, we might look to introduce new community hubs or temporary uses to support the residents and visitors of Meridian Water. So that was a look into just some of the metrics and assessment models that were produced on an iterative basis. Over the course of a few months, the team produced hundreds of models, which were made available to the entire project team and client team via the portal, and all metrics were recorded in a schedule. We also produced a user manual and continue to run training sessions with the client to maximise engagement and promote a collaborative design process. One of the most important and telling tools for engagement was a facing web scene created to visualise how the site might be delivered over the coming years in terms of the phasing out of the existing uses and the competing land ownerships across the site. Overall, the web scenes allow for a much wider audience across multiple disciplines and stakeholders to engage with the vision for the site, allowing users to explore parks, the streetscapes, key views and arrival points within the site, but at the same time to have sight of those all-important metrics just by clicking on the buildings, the plots and other elements within the model. Okay, well that was a quick whirlwind exploration into how we've applied the geodesign approach at Meridian Water. Now I'll just go over a few of the lessons we learned throughout this project. Lessons include defining data types, deliverables, and the integration process from as early in the program as possible. Understanding how the client and project team want to view and/or edit the data themselves is also key to defining the solution. But perhaps most importantly, it is to always question and to challenge the brief. Why are they looking for this digital solution? What digital infrastructure is already in place on the project or will be invested in? And most importantly, what is the long-term strategy and associated value of taking this route? The geodesign methodology is not just a series of tools, but it is an approach that can be embedded throughout the entire life cycle of a project to support the sustainable legacy of a community and a place. Well, that's it from me. So on behalf of Shannon and our project team, I'd like to thank Esri for this opportunity to share our experience and application of geodesign on a truly exciting and forward-thinking project at Meridian Water.